As soon as high school, I was going out and doing jobs, skipping school and going and installing tools and stuff with the tracker. So I've been doing this since 2004. And I started out with the Odolite, which was what we used to use before the trackers and the arms and stuff came out. And then once the trackers came out, we had Insight, which just XYZ super simple software. And then they came out with Verisurf, but Verisurf didn't have the VDI yet. So we would have to actually pull our points in like a cloud and then analyze stuff using Verisurf. And then Verisurf 9 came out, and that had the VDI where you could actually measure stuff straight to CAD. That was pretty nice. Because like I said, we were doing everything to XYZ. You would always remember your probe comp in your head because it wouldn't do any of that stuff automatically. And then from there, we got all the X versions, and now 2024. So what I was gonna go and do today is, we got these 4 pieces of equipment back here. Well, yeah, a little more about my history. I worked at my dad's shop for probably 15 years. Then I went and worked at Northrop for 5 years in California. I was basically the lead tracker, jig and fixture guy, and I trained everybody there. And then now I've been here for a little over 2 years, and I probably learned more here than I did in the first 15 years of using the software, because now I gotta know it all. So here we got 4 different pieces of equipment set up. We have the first thing we're gonna run in there is I'm gonna get this CMM going in the back corner, and then we're gonna get this little equator going. The CMM is retrofitted with a PH20. It's got infinite angles. You calibrate the tip once, it's about 7 or 8 minutes, and you can do any angle you want. What's nice about that is when you go and you pick your features inside of Verisurf, you just say follow feature. You don't go in there and calculate, oh, I need to be 15.5 degrees or 90 degrees. It doesn't matter. You literally just go in there and say follow the feature. Or you can tell it to follow a view. Like let's say we're trying to tuck in on a surface and it's like this. You don't want to follow the feature maybe. You can just literally just put your Verisurf view looking at it, and it's going to follow that view for the measurements. So that's real nice too. And then we got the Faro arm I'm going to be using. Most of you guys are familiar with the Faro arms. I think everybody here has a Faro arm for the most part. That's just a manual CMM, real quick. And then we got the API tracker with a V probe. So we're going to run through that too. And we just kind of want to show you guys that Verisurf can run all 4 different pieces of this hardware, and it's all 4 different brands. Inside of here, if I go to my settings, this shows us all the different hardware we can connect to. So you can see there's quite a bit of different pieces of hardware we can connect to, whether it's a CMM or an arm or a laser tracker. And we're gonna do just kind of like a quick process of how I would program a part, and then how easy it is to change it from a manual Faro arm program to a CMM program. You just literally have to add the paths on there. So I'm gonna make sure I got this set up in here. So I got this set to manual for my automate settings, because we program everything inside automate. So if you're gonna be programming from the arm, you want it to be on manual mode. If you're programming for the CMMs, you can set it to automated, and when you pick the features, it's gonna automatically put a path on there, like a generic path that it thinks is the best for it. If you were to create a circle and edit it, the circles you create after that is gonna make the same way that you created the path on that first circle. So I'm gonna leave it on manual for now. We'll press OK. And then when we're at our programs, of course, first thing we do is our auto line. When programming it, if it's going to be somebody else running it, you really want the automate to be inside the program. So when they start the program, they run through the auto alignment and straight into measuring. You can also run it and just measure like you guys are used to, the people that use Verisurf, and then you can just do a plan for the measurements. So I'm gonna put everything inside the plan. So I'm just gonna go in here, create a new plan. Here's my part. First thing right here is I have auto align. This is just like inside a measure. We're gonna create some targets. Here, here. So if I pull up my print right here, I'm going off my datums. I got datum B on the front, C is on the side, and then A right here is on top. So that's where I'm getting my targets from. So I go right back to here. I'll turn the print off for a second. Back to automate. So I'll pick my B datum and then my C datum. Then I'll escape out of here. So now my alignment's done. This is, like I said, all in manual mode right now. So this would be for an arm or for the tracker. So from here, I'll go back to my print and we can see we got a whole pattern of 8 right here, true pull 14, and it also has a angle 45 on here. So the nice thing about Verisurf is we can do auto holes. It's right here, auto holes. We just click that and I can click this feature and it's gonna automatically click all the similar size features. So if you got like grids of holes on aerospace parts, this is great. Especially when it comes to the PH20, I can pick a grid of holes that has all the different angles across it and I can say follow feature vector. So now all my holes with all those different angles are all programmed, just with a few clicks. So press OK. Then we can edit all these at the same time. So we'll go in here, edit cylinders. We'll go in here, we can check our measure settings. Everything looks good. Okay. Now we can see there's a bolt hole circle. So we're gonna grab all these and we're gonna construct a circle. So now we have our bolt hole circle of the 2750. I'm gonna drag this to the top. So this is gonna be my center point now. And what I can do is I can grab all these features and we have something called multi-construct. I'm gonna go 1 to 2, 1 to 3, 1 to 4. This is basically gonna draw a line across from that center bolt hole circle I created out to each one of those cylinders. Because to check my angle, I need a line. So first thing I'm gonna do is I'm gonna create a line. Okay. So now if we click right here, inside of automate, cylinder 1, we grab all these features, right click, construct, angle. Nope, multi-construct. And now we're gonna go 1 to 2, 2 to 3, 3 to 4. And we're gonna do angle, okay. So now if we look at these angles, now we have angles for each one of these features. All of our 45-degree angles going all the way around. So now we have a circle for our bolt hole circle. We have all the cylinders. We have the lines going around and we have all the angles. So that didn't take very long to program all 8 of those holes. Now if I want to change it to it being an automated program, all I'm going to do is go in here. And what I'll do is I'll grab all these features, right click, generate a path. And we can zoom in on here and see it kind of shows us our path in here. And we can adjust everything pretty easily. We'll adjust our approach to where it's right in the center. We can see we're not going too deep, not too shallow. Okay, so that's all programmed now. And on our alignment, what I like to do is, and what I'm going to show back here in the room is just a single point alignment. So as long as we take our part and we place it in there, we have to make sure our model and our part matches on our X and Y, because it's going to take one single point and it's going to call it perfect. So once it calls that perfect point, then it's going to do an automated routine where it's going to run the alignment and it's going to actually measure all my datum points and it's going to walk around it. So what I'm going to do is I'm going to actually add another alignment in. We'll put this back up top. And when you do this single point, we want to make sure it's somewhere that we can easily visually pick it up. So I'm just going to add a point in right here. Create target. So right here is pretty visually, I can kind of get it between the hole and it's on the radius. So what I'm going to do here is I'm going to go in here and say start device from base. This is pretty important on the CMM especially, and it doesn't really hurt to use it on the arms and the other feature and the other tools either. Basically it's saying get rid of all my previous alignments, because it's very easy to stack alignments without even realizing it. So what you'll notice is when you're running this and you start this program, your Verisurf over here on your device is going to only show one alignment. Where if you go back to some of your old programs that you don't do this on, you'll notice it'll be like auto align 10 through auto align 30. It just keeps stacking it each time. Okay. So we're going to make sure this is a manual point, and then we're going to go in here and we're going to automate each one of these just by going change measure settings and saying automated. Now it's automatically put a path on there for all those features. Here, here. So now you can see it's got a path. So I think these points are purple. I'm colorblind. Are they purple? These points right here?
They're red. Kind of a dark red.
So basically, if it's this color, it's saying that our entry and our exit's in the same spot. If I was to change one of these, for example, this one, see my measure settings, you'll see a green and a red. So green's our entry and red is our exit. But if they match up, that's what it's giving us that color. So now we have our single point alignment, then we have our automated alignment that CMM is going to run. And if we set this up where auto accept on 10 thou, I have this CMM set up back here where I have an auto accept on 5,000 alignment. So basically I take my 1 point and it says, okay, that point's going to be perfect. So it automatically goes and it starts running my automated routine. And once it's done with the automatic routine, if that's within 5 thou, it goes straight to measuring. So really, like if you're doing multiple parts over and over again and you do the single point, you know the part's going to be close enough, it'll just run. And then it'll be done once the report pops up on the screen. So it's really just, you're just doing 1 point, that's it. And then it's hands-free. And that's really, it's that easy. It's that easy to go from, one thing I did forget was need to add a probe. So we're gonna say we got our long probe. We'll say A0, B0. Where is it? Right here. We'll put that probe right beginning. So now this one's ready to be run on the machine. And the nicest thing about it is when we just change the paths and everything on the manual program, if you're a customer that has an arm already, you can just take all those programs that the customer is happy with the reports already. You can just take those programs and add paths, and the CMM's gonna run it, and you're gonna get exactly the same report that you already created and the customer's used to seeing. They're not gonna know that you ran it on a CMM or on an arm or on a tracker or equator. There's no difference across the board, other than you're adding paths in there. So that it's really nice to run it for companies that have all the different devices. It's just universal, the report that comes out of it. And that makes it easier for the engineers, management likes that, and then customers, they're not seeing, how come this guy took 50 points, and then this one took 10 points, but this one shows bad and this one shows good. It's the same across the board. There's no argument between the person that did it with the arm, the person that did it with the CMM, or the tracker, or the Equator. It's all the same. So I don't know if you guys have any other questions other than that.
Where would you use that at, Matt? Would you use that like if they did an inspection, first part on the CMM, got it all lined out, got the report, now they need to do some in-process gauging at the machine and they've got an arm, that would be a good place to do that maybe?
Yeah, so either or. So let's say, of course, when you get parts off the machine, they're like, hey, can you guys check this real quick? And you don't have time to program it. You can check that, and if what you check it with automatically creates a plan. Every report you make is basically a plan. So what we can do is we can just take that plan. Like if I was to go into, let me just go to mouse mode real quick, and I'll do a little example. So mouse, let me turn this off. Let me go to my plan. I'll just measure some stuff inside of okay. Then let's say I measure a line, some lines, and I'm going to project it to that plane I just measured. So now I got a plane and I got some lines, so I'll create a report. Okay. Then let's say we got to get some distances from line 1 to line 3. We'll do a distance. Line 2 to line 4. We'll do distance. Okay. Well, now if I go into automate, and I go and I open up my report 1 right here, since I had it on automate, it basically already created a plan on it. It already made a CNC or a CMM program for it. It put a path across the top, and it made, what it used was my points that I measured. So these are the points I clicked with the mouse, and it basically just said, replicate this, but do it with CMM. I didn't even have to change, I didn't have to do nothing to it. But since I had changed it to be an automated, it did that for me. So that's what it's gonna do for anything you guys measure. If you have it automated, it's gonna automatically do that to the report, or if you had it manual, it would have left it. But this report is already ready to run right now. I can just go over here. So here's my plan. Here's the plan we ran with the arm, let's say. I can just clear it, okay? There. There.
Thank you.
So now I did the part again. And it just used my old report. And this could have been ran on the CMM. So whatever you guys, like Jim's saying, is like if you got a part that just comes in real quick, you don't have time to make a program for it, you can just check it with the arm. And then let's say, okay, that part's good now. My report that I did is good now. Now you can just start running on the CMM. All you have to do is add in the auto line.
So if we're trying to like program multiple probe tips and stuff, you said it kind of generates its own angles and everything. Does it have like a standard for like safety moves and rapids as far as like when a probe is approaching the part? And also like how do you program like a probe change in the first place?
So a probe change is super simple. When you get your CMM, they're gonna help you guys. You guys in particular, Mike will help you guys get all set up with the rack, whatever probes you want. So they'll all be configured, ready to go. And all you'll do is like, so let's say this program, I had to add the probes and the alignment in there. Let's say you want a couple different probes. So we got our long 4 millimeter.
Yeah, that one.
And let's say we want to do a different probe. So we just say add probe, We go in here and we'll say, let's use this little 1x20. That's a nice little short one. We'll press OK. So all we do is we place this one at the beginning. We're going to say, let's start with this probe. And then let's say these lines, you want to use a shorter probe or it's more accurate or something. You just drop it in there and now this is going to do a change. I do recommend going right here and we have add go-to point. So if you click on this feature, line 1, and I click add go-to point, and I'll say before, I'll say clearance plane, let's say 2 inches, okay. If I click on this go-to point, it automatically put it up here 2 inches straight up from that line. So when you click on a feature and you say add go-to point, it puts it straight above it. So if you're going to be doing like a change or something and you're worried about it, basically you just add this go-to point right here, and then from there it's going to give you a go-to point so it'll go to the go-to point, go and do your change, and then come back to a go-to point and go back to measuring. Okay, so like I said, we got the Zeiss CMM PH20. I'll wait for everybody. It's going to be a little bit tight in here. That's everybody. Okay, so we got the arm, we got the Zeiss with a PH20 retrofit. This doesn't come with Zeiss, this was retrofit. The Equator, like I said, this is great for desktop, great for production. This is about half the accuracy of the arm. And then this is about 1/10 the accuracy of the arm, if not better than that. Tracker with the V probe is a little bit worse than the arm because you got 2 different devices you're stacking up now. When I do my single point alignments, when I create the automatic alignment, I always make sure that I give myself about 1/4 inch on my approach. So that way, basically, if I grab this point within 1/4 inch or 1/8 inch, even, usually you're going to probably be able to grab it within 30 thou, as long as you put it somewhere visually. Then you know that when you're measuring it in the automated, it's going to clear the part. So all I got to do is grab this point, and it's going to just take off. It's going to start measuring. I have it all on auto except if it's under 5 thousandths. So it's going to go through and it's going to start measuring the alignment, and then from there it's going to go and it's going to start measuring all features. So now that I'm not worried about this is a proven program, I'll let this run. I'm going to get the Equator going. The Equator, I programmed it a little bit differently. I made a plan for my alignment, and then I made a plan for running my parts. I wanted to do that to show you guys an example of, like, if you were doing fixturing, like let's say you had just a couple 1 to 3 blocks set up, and you're just throwing the part in there and just running it, because you're measuring all your datums. You only really need that one first auto line, and then you can just run your plan in a loop. So you don't have to have the auto line every single time on that part, but you just want it initially, so you can keep it separate in 2 different plans. So over here, I'm gonna run my alignment. Again, it's just a single point. Okay, so now it's going to run and it's going to grab all the other points. And then while those are running, I'm going to get the arm going too. So I'll just clear this program. Okay. And I'll press play. I like to set it up where I do a picture of the setup first, because you can put comments with pictures. So I like to do a picture of my setup, and then I have it pull up the print for myself. So if you have somebody else running your program, sometimes you get pretty complicated setups. That it's not just a matter of gluing a part to a table. Especially if it's like sheet metal stuff, you gotta clamp it a certain way, you gotta push on it a certain way. Then you can put those notes here with a picture, so when the next guy runs it, he's not spending all that time again doing the setup. So press OK. Then I said I pull up the print. I like to put a note here when it pulls up the print, check revision. So whoever's running your program, let's say the parts are like a Rev E right now, and you program the part to a Rev A, they're not going to measure this Rev E part and reject it and say, oh, well, Zach made a crappy program. I followed his program. You're like, no, I told you to check the revision. Don't put it on me. Okay. So this one's done over here with the alignment. So I'm going to get it going on the plan. So now this is just going to run all the measurements. And then we can come over here and run the arm. I got this on auto accept too, so I go back and forth with the computer. So top. I got my middle for my datum D. I got my circles. And I just have them measure the 2-inch. And now we're doing the little holes around the outside. Sphere. Depth of the cone. Line for our angles. Line 4 is, let's get back. Slot. I got these little lines right here. Front surface. And a little analysis. So that part's pretty much done now. I measured all the features that were required on that print, and I have all my constructs done. So I can pull up this report. So I got my datum, I got my bolt hole pattern, I got a screenshot of all my bolt hole pattern, then I got my true position here. And then same thing on the 1875 holes, it had a true position call out. I got a screenshot of my holes. Then down here I did a little screenshot of the front vectors, and I did a screenshot of the little analysis that I did. And I believe if we go and we look at this one over here, the Equator is actually capable of doing scanning. So if you watch, it's actually grabbing it and it's doing a scan across and it's coming out. So it's a little bit quicker than the the standard CMM that has to take points. Because you got a lot less speed up and slow down because it's just going in, dragging across, coming out.